previous video, we looked at limits that were in indeterminate form. We saw that the way to spot them is to substitute the approach value into the function. And if we get 0 over 0 or infinity over infinity, we know it's indeterminate. We then solved them either by factoring, when it was straightforward, or by using a brand new mathematical tool we discovered, L'Hopital's rule, which allowed us to solve these limits quickly and easily. So it's very important to keep these three outcomes separate because each one has its own name. Outcome 1 happens when we can immediately substitute the approach value into the limit without any issues, like in the example where we could see there was no math error anywhere. We just plug it in and get the answer directly. This means the limit exists at its approach value and nothing goes wrong with the function there. This type of limit is called a trivial limit. Outcome 2 is when we get 0 over 0 or infinity over infinity. We call this an indeterminate form. We could solve these by factoring or by using L'Hopital's rule to find the answer. The fact that the approach value gave us 0 over 0 or infinity over infinity means that something went wrong in the function at that value. It caused a hole in the graph. But remember, at a hole, the limit still exists, because the limit exists as long as the right-hand and left-hand approaches go to the same y value. And for a hole, both sides do approach the same y value, so we could still get a solid answer for the limit. Outcome 3 happens when substituting the approach value gives us a fraction where a non-zero number is divided by 0. This tells us we're dealing with a vertical asymptote in the function. We call these infinite limits because the answer is always positive or negative infinity, and we used sign analysis to determine which one. In this video, we're going to focus on a few more types of indeterminate limits that we can get, apart from the usual 0 over 0 and infinity over infinity, and how to deal with them. These are the slightly trickier limits that examiners love to throw into test papers. So, besides 0 over 0 and infinity over infinity, we can also run into other situations that cause problems when we try to take the limit. And because they cause issues at a certain approach value, we know there's something funny happening in the graph of the function at that point. These special indeterminate limits appear when, after substituting the approach value, we end up with one of those weird-looking results that make your calculator want to explode. The good news? With a solid game plan, you can crush these limits. They just take a bit more work than the ones we've already mastered. Now, for our plan of action to handle these new types of indeterminate limits, we're going to group them. The first two types we'll tackle in the same way, and the last three types we'll also tackle in the same way. Remember, an indeterminate limit is when, somewhere in an algebra problem, we hit a roadblock that stops us from continuing with the limit. This doesn't mean the limit doesn't exist. It just means we have to work a little harder to figure out whether it has an answer. For the first two types, we'll always try algebraic manipulation to see if we can sort them out. Sometimes, you need to think a little outside the box with your algebra, as we'll see in the example we're about to do together. After our algebraic manipulation, we'll end up with one of two outcomes. Outcome 1, we get something over 0, which we already know how to handle. Anytime we have something over 0, for example, 5 over 0, we must do a sign analysis to see whether our answer will be positive infinity or negative infinity. Remember, whenever we get something over 0, the answer will always be infinity. Our only job is to determine whether it's positive or negative infinity by doing the sign analysis. Outcome 2, we get 0 over 0 or infinity over infinity, and we already know how to handle these as well. We solve them either by factoring, or, if factoring is too complicated or not possible, by using L'Hopital's rule. Let's work through an example together so we can see this plan of action in action. The full video is only available to our awesome ebook course students. In our ebook course, all your videos live in one place, together with the ebook and downloadable cheat sheets. No more 2 a.m. doom scrolling on YouTube before a test. Everything's in one spot to help you succeed at Calculus 1 the first time. Let's be honest, I'm not here to convince you of the beauty of calculus. I'm not a professor who can talk for 3 hours about how elegant differentiation is. This is damage control to get you through Calc 1 so you can move on with your degree and with your life. This is your please don't ever make me redo this class again plan. And it's all at a student-friendly price that costs less than a mid-tier restaurant meal. Not even steakhouse level, more like a fancy burger with just one side. See you inside the ebook course.